Welcome to Sift Tutorials. Modern wind turbines have a lot of similarities in their designs and how they are controlled, irrespective of their manufacturer and model. The data delivered from SCADA systems to owners and operators also includes common measurements, like wind speed measured on the nacelle, rotational speeds, pitch angles, and output power at a 10-minute frequency. These similarities mean that we can build analytics which will be valuable for all turbine types. To do this, we need to account for some differences as well between sites, such as varying control parameters or signal naming conventions. In this tutorial, we are going to set up a framework where these variations can be stored and used as inputs to the analyses. We will explore how to do this on our Sift Monitor platform. Let's start with categorizing data according to turbine operational modes. We have done this for one site in our last series. Let's have a quick look at the Sift file. The control strategy on which these rules were based generally holds for most turbine types, but the exact parameters can differ a lot between turbines. Here, for instance, we identified idling pitch angle, cut-in wind speed, generator speed cut-in, and rated power. These are all specific to this turbine type. In order for these rules to be directly transferable to other sites, we can create variables where we will store information specific to turbine types. Let's go back to Sift Monitor. Variables can be managed here. Let's add a variable for each of the controls we just mentioned. So we are going to need one for idling pitch angle, generator speed cut-in, wind speed cut-in, and rated power. The names of these variables can be anything, but we recommend avoiding spaces and special characters to make them easier to type out and call from analyses. We also recommend having the signal they relate to be at the beginning of the variable. This will just make it easier to find them. Then we can add each of these variables to our project, and we can set their values. So for pen and shield, we are going to look at the Sift file to see what they were. So idling pitch angle was 46, generator speed cut-in 1140, wind speed cut-in was 4, and rated power was 2060. Let's save this. There we go. Okay, so now the variations between exact turbine controls have been accounted for, but we still have to work around the fact that signal names can vary a lot between sites, because signal naming conventions vary between manufacturers. So here, for instance, the unit is specified in the signal name, and the statistic is only stated if it is not the mean. We can expect certain measurements like power or wind speed from all systems, so we can create a translation layer from the original signal names to a set of standardized aliases. This will allow us to have a unified naming structure across the portfolio. Again, these names can be anything, but we recommend setting up aliases that are easy to understand, quick to type in filter strings, and are not unnecessarily abbreviated, but still include the statistic. At BitBloom, we use a 1 or 2 word description of what the signal refers to, then an underscore, and finally the statistic. Let's create an alias for wind speed. We define the name here, and then we choose the relevant signal for each site. If the signal does not exist, you can mark it as signal not available, like so. This will allow the analyses to still run and generate partial outputs. We'll need an alias for each of the turbine control signals. Let's save this. Cool. Now we're all set up to create some standard flag roles that can be used across all sites. We also aim to have a standard flagging structure, which is useful for analytics focusing on, for instance, certain types of downtime or curtailments. In practice, this means we want to make sure our flags have the same names across the portfolio. We can manage flags here. Let's create our two standard flags for downtime and curtailment. Then we can add the flags to the sites and our standard roles by calling the variables that we defined with the @ symbol. The last thing we need to do to set up our flags is to make sure they are of the correct type. Downtime should be unavailable, and curtailment should be partial performance derated. Save the configuration. Note that this only creates the roles, but does not apply the flags. And that's it. We've covered the basics of creating a standardized framework. This will help us make sure our setup is consistent across sites and enable us to manage analyses centrally. In the next video, we will build on this and create some analytics.